we are using that for that kind of representation. And then you know the representation of chemical structures themselves also makes many problems. Let's say that we can write something like that, or we can write something like that, and it is simply the same structure in which we indicate some hydrogens, or we indicated the position of that and that carbon atom, because we need that for some reasons, to discuss some properties or so on. And however, let's now analyze what is such a structure. What is the meaning of such a structure? And we should understand that such a structure is just hydrogen, 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 and that here is once more hydrogen, hydrogen, hydrogen. So such a representation means that is a methyl group here, or we can write that also in such a way, CH3. It is strictly the same. But let's try if we just change a single thing, I mean with a plus here, we have an sp2 representation, sp2 hybridization, which is also a convention. Any atom does not know that a hybridization is in the sp2 or sp2 or sp3. But now we have a carbocation. So simply something completely different. So we have a hydrogen here also, which is not shown. A hydrogen here, which is not shown. We are not showing it. We should understand that we have a hydrogen here. So we can have many mistakes even in such easy representation of chemical molecules. Then you know then what is important for organic synthesis is to understand also some general way of the representation of chemical reactivity. And so always nucleophile reacts with electrophile to give, nucleophile electrophile representation. It can be also a plus here. So nucleophile, if we have, let's say, the aromatic substitution or double bond, let's say, such as that, it is simply a nucleophile. And this can also be similar way here. It is also a nucleophile. We have the name of the reaction is aromatic electrophilic substitution, because hydrogen is replaced here by this electrophile. But we have always nucleophile with electrophile. It's always the same. So let's say if we have one of the simplest one, we could have such a substitution, and we'll have simply hydrogen and then plus Cl minus, and we have simply a product of addition. What is the name of that addition? It's electrophilic addition to the double bond. And here we'll have the substitution. Why substitution for the aromatic structure? Because aromatic structure wouldn't like to be replaced by a single bond. So we can have a similar reaction with some catalyst. We should have a catalyst here, and we will have the product of the addition, but we should have a catalyst which removes this hydrogen. And for example, it could be for example the Friel-Crafts alkylation of acylation, and let's say if we would write here the more complex RCOCl, yes, RCOCl, and here the catalyst will be, okay, let's remove that. I don't have much space here for writing. Maybe next week I'll go to the institute to have that lecture from the normal lecture room. It will be much easier then. We have a catalyst, and the role of a catalyst is just we will have RCO and plus and RCl 4 minus, yeah, so we'll have such a, yes, such a electrophile. So it is simply an electrophile, and a product will be a Friedel-Crafts acylation product. So we see that there is some regularity in that, and it is very important because this helps us to understand what's going on. We should know the general representation of the reaction. We should understand the reactivity, and then it's much easier to try to find, and it will be very important here during we would try to study the disconnection of the product of a target molecules for reagent for syntons, which will be then composed in reactions. And so it is very, very important to understand that generally what we are discussing is always the same. So although it looks very complex, organic chemistry is much more easier than we could expect if we understand and remember that type of notation. Let's say we can also change the reactivity. So what was here the so the double bond can then be also not only nucleophile, but I'm asking a question, could I have here an electrophile? And the answer, so the double bond, and the answer is yes, we can have here an electrophile. If we have such a group which is, let's say, electro-withdrawing group, for example, a nitro function, then we'll have something like that, which will provide us minus. So we'll have here the electrophile, which could react them with a nucleophile and a double bond. So nucleophile is attacking here, and then we'll have a product with a nucleophile, and it is the so-called okay, that's, or here is double bond, yeah, here should be a double bond, and so we have something like the Michael addition. So we change completely the reactivity of the molecules, which is now much different. We are saying that Umpolung of reactivity. We'll also study that during our classes. And of course, we can have similar situation in aromatic structure when we can also could have electron withdrawing group, and which makes that entity sensible to the nucleophile attack for that aromatic structure. Okay, so now we'll take a short break, and what I would like now to present you will be to study now and a short after the break, because we'll meet after the break, so it is 10:30. I think that we are starting the seminary, but I'll send you once more the link for studying the the problems of the working in groups. Let's say, I'll see if it is what I would like you to study.
Out there with our customers. And these are the three main problem areas that we see.
The perfect version of themselves.
That's not that one.
Yes, before the meeting.
Yes, that is that one.
$67. You can make as many videos as you want, and you never need to pick up a camera or use any fancy editing software. With Doodly, you drag, you drop, you tweak some settings, and boom, video done. It'll take you just a few minutes.
Okay, so what I would like you now is to try to watch this video in internet. I'm not presenting that through the network, because then the voice cannot be are distorted, so the quality is very low if I transmit that through the Teams, but you can use it locally and see, because what I would like you today is to try to form the groups. So let's say that now and after the break I'll give you, let's say, about 15 minutes, so, or even, yeah, 15 minutes. So let's meet at 11:45, okay, at 11:45 to discuss the problems for the seminary. Czyli zrozumieliśmy się? Teraz przyglądnijcie te, które posłałem, linki wcześniej, i teraz ten link poświęcony pracy w grupach, tak żebyśmy mogli w tych grupach pracować, a później spotykamy się na seminarium, powiemy sobie 2 słowa i potem chciałbym, żebyście wy popracowali. Pokażę wam zaraz, jeszcze też podeślę linki. Tak. Nie, to pierwszy link. Tak, jeszcze 2 linki. Wobec tego spotykamy się o godzinie 11:45, ok? Słyszycie mnie?
Tak, słychać.
Super. To 11:45 spotykamy się na te drugie ćwiczenia, a teraz można i przez te pół następnej godziny przejrzeć te linki, które podesłałem. Dobra?
Dobrze.
No to na razie.